Okay, we had a question about section 1.4, problem number 30. They give you a triangle that looks like this here, and they've told you the hypotenuse is 1, one of the legs is C, and they've asked you to come up with the sine and the tangent and the cosecant of this angle here, which they are calling theta. This is a really good problem to go over. One of the things that bothers people about this is the idea that one of the sides of the triangle is missing, and they feel like that needs to be known. So what a lot of people like to do, which you can't, is just randomly make up a new variable, like call this m, and then use that value of m over here in any of your answers. Like, for example, tangent of theta would be c over m, and that would be correct if I was allowed to just make up a new variable. But really, mathematically speaking, we never want to get in the habit of just randomly making up new variables because it makes it sound like we don't have any information at all about what that third side is, when in actuality, we do. Anytime you're given two sides of a right triangle, you can always find the third by remembering your Pythagorean theorem, even though in this case it's poorly labeled and misleading. A squared plus b squared, nope, is equal to c squared. Now they've used c for one of the legs though, which is odd. So here's what we're going to do. I'm going to temporarily, I'll come back and change this, call this missing leg A. So one of my legs is a squared, plus my other leg, which is c squared, has to equal my hypotenuse, which is 1 squared. Now I know that relationship has to be true. Now what I'm going to try to do is solve for a in terms of c. So the first thing I'm going to do is bring this c squared to the other side and get a squared is equal to 1 squared is 1, and then minus c squared at the end of that. And to get a by itself, we'll take the square root of both sides of this equation, and we'll get a equals. Now remember, algebraically, there would be a plus or minus that we would have to write here in front of that square root. But this is a geometry problem, guys. There's no way that the length of this leg here can be negative, so we're good with just the positive square root of 1 minus c squared. Now that might not seem like much, but what that is the representation here now for the length of this third side of the right triangle. So I'm going to go ahead and label this side, what I know its length is, the square root of 1 minus c squared. And now with that in mind, answering these three questions shouldn't be that bad. Actually, as I look at it now, sine of theta we could have done right off the bat. Opposite leg over hypotenuse, sine would be c over 1, or just plain c. Tangent now would be opposite leg over adjacent leg, so that would be c over the square root of 1 minus c squared. And remember, for the last 2 years for you guys, in Algebra 2 and in pre-calc, you would have had to rationalize this by multiplying by the square root of 1 minus c squared over the square root of 1 minus c squared. And that would get you, don't even bother writing this down, guys, c times the square root of 1 minus c squared all over 1 minus c squared. Now that answer is certainly correct, but the good news is, guys, at this level, we don't have to rationalize denominators. That's a grading guideline that I've taken from the AP test themselves. They say you don't have to rationalize denominators, so it's perfectly okay to leave the answer in this form here. And then cosecant, of course, is just the reciprocal of sine, so I don't even need to look at the triangle here, guys. I just need to take the reciprocal of my answer from the first part, and that is going to be 1 over c. So I think the sine and the cosecant part of this problem weren't too bad to come up with. Most of you probably got that on your own, but this tangent piece right in the middle involved all of this work down here so that we could figure out the length of the third side without resorting to having to make up a new variable. Anytime we can avoid that, we should.